So in the previous video we have just finished the chapter number 4 and now we will start our new chapter, that is chapter number 5, Introduction to Euclid's Geometry. So we will see what is the introduction of Euclid's geometry. See here, this chapter is mostly in the theory. So first of all, let us see one by one all the points in this chapter. Let us see that the word geometry comes from the Greek word geo means the earth and metry means the measure. So what is geometry? First of all, students, I am writing that. So geometry. So first of all, what is geo? So geo means what? It is a Greek word, earth, and metry means to measure. Okay students, metry means to measure. Now next point, that is geometry appears to have originated from the need from measuring land. This branch of mathematics was studied in various forms in very ancient civilization, but in the Egypt, Babylonia, China, India, Greek and the Incas, etc. the people of this civilization faced several practical problems which required the development of the geometry in various ways. So why this geometry is used? So we know that the land is measured. The land is measured. If you want to buy a house or a land, then what you see, how much square feet it is. So how it is measured? How it is measured? So this is the theory of that Euclid's geometry. See one by one. See here. There is an example given over here. I am just drawing that. And just we will understand that example. So there is a structure like this. Okay students, there is a structure. This is the front view and this is the back view. Okay students, this is the front view. Sorry, I have this line is to be drawn with curve. So this line will be like this. Okay students, so this then connected. So this is like a 3D structure. Here is the midpoint given and this is the breadth B and this is the A, and here there is a line you can see, that is height H. Okay students, so this is given. Let us see one by one all the points given in that. See here I have drawn a 3D structure. Okay students, but you have to just imagine that it is a 3D structure only, because I don't know the drawing perfect. So next, for example, whenever the river Nile overflows, it wiped out the boundaries between the adjoining fields of different land owners. After such flood, these boundaries had to be redrawn. For this purpose, the Egyptians developed a number of geometrical techniques and rules for calculating simple areas and also for doing simple construction. The knowledge of geometry was also used by them for computing volume of granaries and for constructing canals and pyramids. They also knew that correct formula to find the volume of a truncated pyramid. See, you can see in this figure, 5.1 figure, you know that the pyramid is a solid figure that the base of which is a triangle or a square or some other polygon, and its side faces are triangles covering to a point at the top. Okay students, now in India subcontinent, executives at Harappa and Mohenjo-daro etc. show that the Indus Valley civilization about 3000 BCE before Christ made utensils use of geometry. It was a highly organized society. The cities were highly developed and very well planned. For example, the roads are parallel to each other and there was an underground drainage system. The house has many rooms of different types. This shows that the town dwellers were skilled in the measuration and practical arithmetic. The brick used for construction were clean fired and ratio length between breadth and thickness of the bricks was to be 4, 2 and 1. In ancient India, the Sulbarastra 800 BCE to 500 BCE were the manual of geometric construction. So here is the theory about the old, when these geometry just started in India or in Egypt or in anything else. Okay students, so I am just reading so you can just understand that. So the geometry of the Vedic period originated with the construction of altars or Vedis and fireplaces of performing Vedic rite. The location of the scared fires has to be in accordance to the clearly laid down instruction about their shapes and areas if they were to be effective instruments. Square, circular altars were used for household rituals, which altars shape were combining of rectangles, triangles and trapezium were required for public worship. The Sriyantra given in the Earthveda consists of 9 interwoven isosceles triangles. These triangles are arranged in such a way that they produce 43 subsidiary triangles. True accurate geometric method were used for the construction of the altars. The principle behind them were not discussed. See here the Sri Yantra. Here they are just talking about the Sri Yantra. I can say that any of you have at home the Sri Yantra. It is there, Sri Yantra. I have just heard, I haven't seen that about the Sri Yantra. In that there are, it is the mixture of, you can see 9 isosceles triangles. In that they produce 43 subsidiary angles, triangles in it. Okay students, and this next is, this example shows that the geometry was being developed and applied everywhere in the world, but this was happening in an unsystematic manner. Means they don't have any systematic manner, they just do unsystematically. Okay students, and next is, what is interesting about this developments of geometry in ancient world is that they were passed on from one generation to next, either orally or through palm leaves message or by other ways. Also we find that in some civilization like Babylonia, geometry remained a very practical originated discipline, as was the case in India and Rome. The geometry developed by Egyptians mainly consists of the statement of results. There was no general rules of the product. In fact, Babylonians and Egyptians used geometry mostly for practical purpose. Means here you can see that it is given that in the Egyptian there are only the theory part. The practical part was not just applied in that, but in the Babylonian Egyptian used geometry most practical purpose. They just used most practically and did very little to develop it as systematic science. But in the civilization like Greek, and the emphasis was on the reason behind why certain construction work. The Greek were interested in establishing the truth of the statement they discovered using deductive reasoning. See here, Thales in the appendix 1. A Greek mathematician Thales is credited with giving the first known proof. The proof was of the statement that a circle is bisect, cut it into two parts by its diameter. One of Thales' most famous pupils was Pythagoras, whom you have heard about. Pythagoras and his group discovered many geometric properties and developed the theory of geometry to great extent. This process continued till 300 BCE. At that time, Euclid, a teacher of mathematician at Alexandria in Egypt, collected all the known work and arranged it in the famous treatise. Okay, students, and then after here called Elements, he divided the elements into 13 chapters, each called a book. This book influenced the world's understanding of geometry for generation to come. In this chapter, we shall discuss Euclid's approaches to geometry and shall try to link it with present day geometry. Okay, students, so here we will study about the Euclid's geometry, how he just developed the geometry. Let us see one by one. I am just reading and some of the points are to be explained, then I am explaining or else reading. So the easy points I am just reading, so you can just know that this is done. And Euclid's definition, axioms and postulates. Let us see that. The Greek mathematician of Euclid time chose of geometry as an abstract model of the world in which they lived. Their notions of point, line, plane and so on were derived from what was seen around them, from studies of the space and solids in the space around them. An abstract geometrical notation of a solid object was developed. A solid has a shape, size, position and can move from one place to another. Its boundaries are called surfaces, means the solid which have the specific shape, volume and they have what? Its boundaries are known as surface of it. See here, this is the surface of the board. Okay, students, this is the surface of the board. And next is they separate one part of the space from another and are said to have no thickness. The boundaries of the surfaces are curved or straight lines. This and lines ending points. See, means if I talk about the board, then you have seen board at school that they have directly like this. The structure at the point, at the end, they have like this, or they have like this a curve, or they have a point. Both have point, but here there is curve and here there is an angle between that, right angle. Okay, students. Moving further, consider the three steps from solids to point. In each step, we lose one extension, also called a dimension. So a solid has three dimensions. A surface has two, a line has one, and a point has none. Euclid summarized this statement as definitions. He began his exploitation by listing 23 definitions. Book 1 of the Elements. A few of them are given below. See here, from book 1, some of the main points are given over here. Let us see one by one. See here, a point is that which has no part. See, if I do a point over here and it has no part. Okay students, it cannot be part. And the second one is a line is breathless length. Means you can draw a line very long up to you can. Okay students, we can draw a big line. How much you can just draw? That much big line you can draw, a straight line or curve line or anything else. The end of a lines are always points. See here. Here I have drawn a line, and here are ends of the lines have points only. That is our third point. A straight line is a line which lies evenly with the points on itself. See, the straight line is an evenly line and points are in itself only. A surface is that which has length and breadth only. Means if I talk about the surface, this is the surface of the board. So it has only length and breadth. If I talk about whole board, then it also have thickness. You can see here the board is this much thickness. From here you can see this much thickness is there over here in the board. But we are just talking about the board surface, that it has only length and breadth. Okay students, now next is the edge of the surface are lines. So the edges on the surface, edges which are given, that are lines. Okay, and the next is a plane surface is a surface which lies evenly with a straight line on itself. So the plane surface have evenly lines on itself. And if you carefully study this definition, you will find some of the terms like part, breadth, length, evenly, etc. need to be further explained clearly. For example, consider his definition of a point. In this definition, a part needs to be defined. So suppose if you define a part to be that which occupies area, again an area needs to be defined. So to define one thing, you need to be define many other things, and you may get a long chain of definition with an end. For such as mathematical agrees to leave some geometrical terms as undefined. So if I want to define anything, so first of all, if I define a fan, then what will happen? What I can say? So the fan gives us what it gives. I can't listen, students. Speak some loud so that your parents can also hear that the student is just seeing video and learning from that. Okay students, so fan gives us wind, and it does not, in the summer we know we just pass the fan. Why does the fan rotate? We need to define that. Why does it rotate and how it rotates? If here it was it, then for one definition you have to give also other definitions, and in the maths some geometric terms are undefined. However, we do have a intuitive feeling for the geometrical concept of a point, that what the definition above gives us. So we represent a point as a dot, even though a dot has some dimensions. Yes, if I put a dot over here, then it also has some of the dimensions. Okay students, but a similar problem arises in the definition to above. Since it is referred that to breadth and the length, neither of which has been defined. Because of this, a few terms are kept undefined while developing any course of study. So in geometry, we can take a line and a plane as undefined terms. See, then what is line? We can define that, and what is plane? That is also just undefined. Okay students, then the only things is that we can represent them immutatively or explain them with the help of physical model. Okay, we can say that this is a point or this is a line. Okay students, next is starting with his definition. Euclid assumes certain properties which were not to be proved. These assumptions are actually official universal truth. We divide them into two types, atomics and postulates. He used the term postulate for the assumptions that were specific to geometry, common notion. On the other hand, we have assertions used throughout mathematics and not specifically linked to geometry. For detail about axiomatic and postulates, refer to Appendix 1. Some of Euclid's axioms not in his order are given below. Things which are equal to the same thing are equal to one another. See here, things which are equal to the same thing are not one another. If equal are added to equals, the wholes are equal. If equals are subtracted from equals, the remainder are equal. Things which conclude with one another are equal to one another. The whole is greater than the part. Things which are double of the same thing are equal to one another. Things which have halves of the same thing are equal to other. So these are some of the points which has given by Euclid. These common notions refer to magnitude of the some kind. The first common notion could be applied to plane figure. For example, if an area of a triangle equal to area of rectangle and the area of rectangle equal to that of a square, then the area of triangle also equal to the area of square. See here, this is an example given over here. Just I am trying to explain you so you can just understand it. So here there is a triangle given you and its area, if I take it is the area of triangle is 15 and here a rectangle is given to you. This is a rectangle and its area is also 15 and here a square is given to you and its area is also 15. Then the area of triangle and area of square are equal. Okay students, this is explained in that point. Next is magnitudes of the same kind can be compared and added, but magnitudes of different kinds cannot be compared. For example, a line cannot be added to a rectangle, nor can an angle be compared to a pentagonal. The fourth axiom given above seems to say that if two things are identical, then they are equal. The other word, everything equals itself. It is the justification of the principle of superposition gives us the definition of greater than. For example, if a quantity B is part of another quantity A, then A can be written as sum of B and some third quantity C. Symbolically, A is greater than B, means that there is some C such that A is equal to B plus C. Okay students, that you have studied. Now postulate 1. See here, now let us discuss Euclid's 5 postulate. So the first postulate is, I am just writing that on the board, so it just I can explain to you. So the postulate 1 postulate number 1, that is a straight line line may be drawn from any one point to any other point. Any other point. Okay, students, you can see here it is written that a straight line may be drawn from any one point to any other point. So if you want to draw a line, if I have to draw a line over here, I have drawn that. So what happened? It is just started from this point and ended at this point. Okay, students, so in the postulate 1 it is said that a straight line may be drawn from any point to any other point. Wait. Okay, students, there was a focus option given over here, so I just forgot it to just focus the board. So some of this will see you black. Okay, students, for that sorry students, and just we will move further and go to the next postulate. See here it is given that give two existing point, there is a unique line that passes through them. So if I take any point, see, if I take this point and this point, so what you can just do, you can make a straight line over here. So you have made, if I do a point over here or a point over here, then from that also you can draw a straight line. See students, you have drawn that. So this is just trying to explain in the postulate number 1. And now just moving to the postulate number 2. So what is the postulate number 2? Let us write on the board, students. So postulate number 2 is a terminated line can be produced infinitely. So postulate number 2, a terminated line can be produced indefinitely. Okay, students, it can be produced indefinitely. How? We'll see here. In the first, I have drawn. If I draw a line over here, a definite line with joining 2 points. So this is the point, and they are just saying that you can just a terminated line can be produced indefinitely. So this line also can be produced from here. Okay, students, that is trying to be seen in the postulate number 2 and postulate number 3. Let us see that. So the postulate number 3 that is given a circle can be drawn with any center and any radius. Okay students, a postulate can be drawn with any center or any radius, and the another postulate, that is postulate number 4. Postulate number 4, that is all right angles are equal to one another. Okay, so the postulate number 3 and postulate number 4, let us see that students. In that postulate number 3, it is saying that a circle can be drawn with any center and any radius. If I say I want to draw a circle, then this is the center and this much is the radius, then I can draw a circle like this. So this is not proper, I think, because I don't know drawing. So I can just, what I do is first make a circle, then put a point and draw a radius. Okay students, so if you can't just hold this here from this side, then you can just hold from that side. So I just do like this. Okay students, you don't have to do like this. You have to do like this only. First of all, you have to make a point and then after radius and then after circle. Oh, it's good enough. Yes or not students? I think this is more good than this and this. This is good. Okay, and next going to postulate number 4. All right angles are equal to one another. So if I take a right angle triangle over here, so you can see all the other are equal. Okay, so all right angles are equal to one another. See, if I draw over here a line, then this is also same, but I can't draw same. This two must be same. Okay students, now if there is a square, so if you draw a diagonal, see, this is 90, this is 90, this is 90 and this is also 90. So all right angles are equal to one another. So this areation, this areation, this areation and this area is also same. And postulate number 5, that is big, so I will not write that on the board. I am just reading and explaining it. If a straight line falling on two straight lines make the interior angles on the same side of U taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on their side on which the sum of angles is less than two right angles. See here, for that there is an example given. You can see that example and you can just understand it. And now time for your homework students. So in your homework, what you have to do is, so in your homework, postulate one to 5. How many times students? 5 times. No, 3. No, 2. No, 3 times. Okay students, now we will meet in our next video. Okay, bye students.